got another problem up here on the board. We're going to let f of xy be e to the xy. And I would like to find f sub y. That's the partial derivative of f with respect to y at this point, natural log of 2 comma 1. Okay. Remember, if I'm taking the partial derivative with respect to y, I'm letting y be my variable, x gets held as a constant. Okay. And I want to do this problem two ways. Okay. So first of all, I want to just find a formula for that partial derivative and then evaluate that by plugging in this point, plugging in natural log of 2 for x and 1 for y. Okay. And then the second way I want to do it is by creating an actual function of one variable. Create a function of just y. I've chosen to call it g of y. And I'm going to create that by holding x constant at the natural log of 2 and then evaluating f at the natural log of 2 comma y. Once I've done that, then I can take the derivative of that function and evaluate it at 1. Okay, so let's try the first one. Okay, so I want to take the partial with respect to y of e to the xy. Okay. So what I'm doing is I'm saying y is a variable, x is a constant. I don't know what constant it is. I know eventually it's going to become natural log of 2. But just treating x as a fixed but unspecified number. So I'd say, okay, the derivative of e to the something is e to the something, so I would get e to the xy. Chain rule, I would have to then take the partial derivative with respect to y of x times y. But if x is a constant, that's just a constant multiple of y. If I were taking the derivative of 2y, I would get 2. If I were taking the derivative of 3y, I would get 3. If I'm taking the derivative of xy, I'm going to get x. And usually I would write that factor of x up front, just so that it's super clear if my handwriting gets sloppy that that x is not part of the exponent. It's being multiplied by that exponential expression. Excellent. So that's a formula for the partial derivative with respect to y. Notice that formula does have both x's and y's in it. So now I can say if I wanted to evaluate this, at the point natural log of 2 comma 1, I'm plugging in natural log of 2 for x and 1 for y. Of course, natural log of 2 times 1 is just natural log of 2. E to the natural log of 2 is 2, so I'm getting 2 natural log of 2. Okay, excellent. So there I said x is a constant, but I didn't actually plug in what the constant was until the very end. I just treated it as a constant throughout. With the second way, we're going to say x is a constant, and we're going to plug in that constant first. So I'm creating g of y, which is my function f, but evaluated when I hold x constant at the natural log of 2. Okay, so that's just going to be e to the natural log of 2 times y. Okay, and so now I want to take the derivative of that and evaluate it at 1. Notice this function right here, this would be what I got in the plane x equals the natural log of 2. That would be parallel to the yz plane, and it would look something like so. It's an exponential growth curve. Okay. And we're going to be taking a look when y is 1, so we're essentially calculating the slope of that tangent line that's tangent to this cross-sectional curve. Okay, so g prime of y is just going to be e to the natural log of 2 times y, chain rule, times the derivative of the inside part, which, oh my goodness, is a constant times y. I'm going to get that constant. So I'm going to get times the natural log of 2. I'm probably going to just rewrite this. This is the natural log of 2 times e to the natural log of 2 times y. Okay, and then if I wanted to evaluate that at 1, g prime of 1 is the natural log of 2 times e to the natural log of 2 times 1. E to the natural log of 2 is 2, so I get 2 natural log of 2. Okay. So either way, I get the same answer. Okay. It's generally going to be much more efficient to do things this way, because this gives me a formula that works regardless of which constant x is, so that I don't have to do this for every single x value. I can say, okay, here's my formula for the partial derivative with respect to y, and then I will plug in both x and y. Oh, I've erased that one. I will plug in both x and y at the very end. Okay, but I'm not recognizing that x is a constant. So even though I'm not plugging in the constant first, I'm treating x as a constant as I go through this process of taking the derivative.